Question 10 deals with the influence of outliers in a scatterplot. So we have a lot of things that an outlier can do. And let's look at a few things right here. Can an outlier increase the correlation coefficient? Let's take a look at an example. Here we are with a correlation equal to 0. There is no correlation between these points. If we put a circle, it would be a perfect circle right here. But let's add in an extreme outlier. Now, all of a sudden, with this one extreme outlier, we have a correlation of 0.98. And it actually makes this relationship. Before, there would be no correlation between these points. But one point right here increases the correlation, just the R right here, to 0.89. So we can see how 1 point can make a correlation a lot stronger. Where we had 0 correlation before, we now have a perfect or near perfect positive correlation. It's not quite 1, but it is extremely strong. It is a near perfect positive correlation just due to 1 point, and that's with the point, and then without the point, it would be basically 0. Here we are with a perfect positive correlation, and that's because the points go upwards. The slope of the line wouldn't matter. The points going upward on a perfect line is perfect positive. And let's put a point right over here. And you notice now it's basically 0. With this in mind, we could have a very strong positive correlation, but all of a sudden a point way over here makes it very near to 0. Even more, we can already answer some of the other questions because we can see we have a perfect positive correlation, and if we put a point down here, it's now a moderately strong negative correlation because a line would go through about like this now. All of a sudden, we went from perfect positive to moderately negative. So it's pretty easy to see if we can change the correlation coefficient from positive to negative, we could also make it negative to positive. So in short, outliers can drastically change the correlation coefficient. It can make it stronger, it can make it weaker, it can make it positive, it can make it negative, it can make it 0. So all of the above options are possible. The next question goes along with correlation, so we're doing it right here. Now, it's important to know when correlation is positive 1, it doesn't tell you anything about the cause and effect relationship between the two variables. Even if we have perfect positive correlation, which is actually easy to get. If you just have 2 points, you'll either have positive 1 or negative 1 or undefined if it's completely flat. So as we can see, 2 points having perfect correlation doesn't mean anything about changes in X causing changes in Y. Finally, what is the most likely correlation coefficient for the scatter plot below? And one thing you'll notice right away is that the correlation is positive. We can talk about the strength, direction, form, and unusual features for this plot. The strength has to be strong because the points are pretty close together. The form is linear because it is well approximated by a straight line. And the direction would be positive, and there's not really any outliers. The points that are scattered about are pretty close to the bivariate relationship. So since we said strong right here because it's pretty tight, we need something closer to 1. But why can't it be 1? 1 is only if all the points are exactly on a straight line. So these are points that are off the line, so it can't be 1. The next number is 0.98, and that looks like a good answer. Now you might say that looks too strong, but 0.5 is the next highest answer, and that is definitely wrong. 0.5 would be a moderate correlation, and these are a lot tighter than 0.5. If you're looking for a little bit of help and what might be good guidelines, the Wikipedia picture below has a great guideline of where -1 would be, 1 would be, and all the numbers in between at -0.8, -0.4, 0, 0.4, and 0.8. And you just have to imagine what would be between, but these are generally good reference points to kind of understand.